Sanchay sir is the founder of Hackers Villa. And if I'll talk about the experience of Sanchay sir has shared his expertise at top institutions like Triple IT Delhi, NIT KKR, KIT College, VIT Chennai, DTU Delhi Technical University. And he is leading security meetups and conferences like Null, Crackon, B-Sides, and DEFCON. Like I attended his sessions. I actually met Sanchay sir during his on social media Instagram. I saw a lot of reels of him and they were insightful. So I messaged him for this session and he was ready for this. So he has given some corporate trainings also in Upgrad, KPMG and Cognizant. Today he will be giving a session on reverse engineering and game hacking. So thank you all for joining this. So it's your session now, sir. Sanchay sir.
Okay, thanks a lot, Nipun. Thanks a lot, Sanjeev sir, for the opportunity, first of all. And hope so I'm visible and the screen is also visible. Please let me know once.
It is fine, sir.
Yes, it's visible.
Cool. So really sorry, I do not have that mic right now. I'm at my home right now, just for the Diwali break. So yeah, let's start with the session. And we will be talking about reverse engineering and game hacking. So obviously we will be going through with what is reverse engineering and how actually industrial level work is performed in reverse engineering. Like obviously we cannot go very much onto the advanced side of reverse engineering just in the first session, but yes, I'll try to cover as much aspect as I can and will connect it to game hacking, because obviously game hacking is something that needs a lot of reverse engineering and needs a lot of analysis of the things, how everything is built. So I'll be trying. I do not have any presentations as of now, right? That's just the beginning part of it, and we'll be doing everything practically, right? So do the audience have chat access?
Yes, they have.
Okay, cool. Let me just open the chat as well. Okay, so I have chats on my other screen, right? So if anybody of you might want to ask any question in between, please feel free to ask, because the more better it would be to have a good conversation. Obviously it would be a much better session, right? So starting off with this, right, Nipun has already given my introductions, right? So I had this who am I slide with me. So who am I? I'm a gamer. Obviously every boy is, right? You start your things when you get a laptop or a computer, you start with gaming, right? How many of you are gamers over here, or how many of you have played games like GTA San Andreas, GTA Vice City types of game, Assassin's Creed, Prince of Persia? How many of you have played these games? CS, okay, Counter Strike, obviously. So Valorant or other players? Right, Dark Souls 3, that is really good, right? Okay, Call of Duty. I don't want people who are into BGMI and all, because I don't consider BGMI, Free Fire, and all these things as video games, right? These are just simple battle royale. Okay, RDR2, one of the best, right? Okay, cool. So we have these things, right? So the point is that games, I don't know about girls, but it's for boys that when you play your first game and when you finish your first game, right, you basically get attached to it. So that was my story into cybersecurity, right? So I'll just share that with you. So yeah, from gamer to game hacker, that is my story. And in the mean time, in the between, I've also founded a community, Hackers Villa. It's called as Hackers Villa Cybersecurity Private Limited, where we try to teach cybersecurity, and we have a lot of cybersecurity based trainings over here. Then I have worked with Make and Turn, and right now also working with Upgrad, designing their cybersecurity courses and delivering. Then OWASP Delhi, a mentor of OWASP Delhi chapter, B-Sides Noida chapter, and I've given a lot of corporate trainings at KPMG, Cognizant, and as Nipun has covered, I'm an active part of all these communities as well. Also, right now I'm leading Null Delhi chapter, right? So what is my journey from a gamer to a hacker or a trainer is, right, if I start from the very basics, right, I started in my class ninth, right now I am graduate, I got graduated in 2020, and it's been 4 5 years, right? So the point is, before that, right, if I go back to 2015, so that was my time when I was basically my class ninth, and my father got his first laptop, when I was in my eighth class. So that was also because he got into a company which provided him the laptop, because I come from a very middle class family, and that basically means that you do not have access to a lot of tech. You basically have to go to cyber cafes to do all the work. So that was my life, and when I got the laptop, I got so much indulged into the tech thing. And what took my interest, what piqued my interest was GTA San Andreas. Obviously, at that time when I played that game, it got just it captured everything of me, right? It was like, let's just do something with this game, right? Because what happens is, when you are playing a game, you get attached to it. And after ending GTA San Andreas 3 times, it was something that I wanted to do something with that game. What I wanted was to put a cheat code, put my name as the cheat code, and to get that cheat code activated, thing popping up in the game, and my favorite vehicle should get spawned. So I wanted to create my own cheat codes. I wanted to do something with the game, something extra with the game, create modifications, create gun modifications, create all these kind of things. So when I started with those things, obviously I wanted to learn how it is built, right? So one of my friends said that it's mostly in C++, so you will be obviously taking C++ in 11th class, so why not just understand C++. So I was in my ninth and I started learning C++, right? Took a application, 7 8 MB application, solo learn. It's available on Play Store, and I use that application to just learn the syntax of the language. Obviously, in 6 7 days you cannot learn the language by heart, but you cannot code actually, but you can actually understand what the code is trying to say. So I was able to understand the code. Later I realized it's C hash, and going with it, I tried creating a lot of things. And in my class 10th, I got successful by creating certain cracks of certain other applications like Adobe or something like that. You might have seen a lot of cracks in torrent, right? How many of you has used torrent in your life anytime, when you are small, or even still if you're using it? How many of you use torrents for downloading games and for downloading other things, right? Because daily, obviously, right, it's a very crucial part of our lives, right? So torrent is something where you get the cracks. And you remember, when you get the crack, what you do basically, you replace the exe file with the exe file you get on the torrent, and the game gets cracked, right? So this is what I'm going to show you right now, because this is what I used to build at that time, right? So I was basically building a lot of cracks, and I published certain cracks as well, and got famous. It got taken down. I started a YouTube channel. A lot of videos were taken down as well at that time. So that piqued my interest in tech and hacking. I didn't realize I was doing reverse engineering, but it was so awesome, and it was so fascinating for me that even after doing a lot of things right now, after a training period, when my training period got started, I started giving trainings, going into conferences, becoming a part of these things. Whenever I get a small amount of time, I go ahead, play games, or I hack the games. That is my me time, actually. So yeah, that was my journey, and I started with that. Right, later in the life, in class 11 12, I got introduced with bug bounty hunting and other things. So cybersecurity is a huge domain, right? Cybersecurity is a very huge domain, right? I'll be sharing certain resources over here, right? But let's come to the resources by the end of the session, right? And I have been doing a lot of things since then, right? I did bug bounty hunting, I did VAPT, I did some VAPT internships, I did cloud security things in an internship. So I learned that way, right? And later I realized, no, the best part that I find myself indulged in is reverse engineering. So that is why I love reverse engineering, and I love to do a lot of things with it, right? So if I go back to reverse engineering, it started with it basically started with what we can say, transistors, right? So you need to understand transistors or the registers. basically when once we want to go into reverse engineering. Are you going to show CTF? See, CTFs are very different things, right? Because CTF is something that is a playable thing where you basically get certain challenges and you solve that challenge. So there are a lot of challenges in a CTF, and for those people who do not know what a CTF is, it's a catch the flag. Right, so it's catch the flag. It's just like treasure hunt for cybersecurity people. So you basically have to get the hints or take the hints, and please do not annotate. So basically get to go ahead and capture certain files or flags that are there in the system by hacking it. And you can do that, and ultimately by learning certain things, like you get to know a lot of things in the flags, right? For example, certain flags would be captured by doing reverse engineering. Certain flags can only be captured through a web application, vulnerabilities. So it's divided into categories, right? And the best website to spend your time on if you're learning CTFs or if you want to play CTF is ctftime.org, right? So this is one of the best website, and I'm just copy pasting it in the chats, so you can just bookmark it or save it anywhere. So ctftime.org has a lot of CTFs that are coming up right now or that are just running right now. So you can just go ahead and practice in those CTFs, create your own team, and also just meet new people through the communities that they might have, right? So these CTFs are like all the worldwide CTFs. Even if in India some company or some university organizes a CTF, they would basically be uploaded over here as well, right? So you can go ahead. USC CTF is really good, right? So you can basically go ahead and learn through CTFs as well, right? But let me tell you that CTFs, if you go with the challenges of CTF, it's a little bit different from the real world, right? Real world examples or real world scenarios are a little bit different than how the CTFs are basically built, right? Because CTFs are actually built with a vulnerability taken in hand, right? So they know that there is a vulnerability, but in real world you might not have those vulnerabilities as well, right? So it's a like 50-50 chance in real world that you might get some vulnerability or not, but in CTF you have 100% chance, right, that you will get a vulnerability. It's just basically your knowledge level, right? That is the thing. So TryHackMe is good, right? TryHackMe, Pico, CTFs, they are good. You can try and practice if you want to go further in cybersec, right? Let's come back on the topic of reverse engineering, right? Just in case if you have any questions around the topic, you can just ask me in the between. But if you want to have questions regarding the cyber security other than RE domain, I guess we can discuss about that in the end, right? So going into RE, right? So yes, we are going to cover Gitra as well, right? If we get time, mostly we'll be going into R2 and GDB, right? So if I go ahead, right, we will be going or we'll be talking about transistors, right? So when the computers started building, right, transistors is something that uh, were needed, right? Because why transistors? Before transistors, we had vacuum tubes, right? And vacuum tubes were huge. They were actually huge. Building a computer out of vacuum tubes was actually very much hassle. And you might all have heard of the name Charles Babbage, right? Basically the father of the computer. So if I go back, he was not the actual father of the computers. Before, if you go back a little bit, you'll see that Alan Turing is the main person who started using vacuum tubes to build a certain small thing, to basically break a small code, right, that were coming from Nazis, right, so that he can, he can understand that when are Nazis going to attack on America. So this was basically in World War II. So that was the need at that time, and Alan Turing basically is one known for computer science award is basically named after Alan Turing, right, as well. So vacuum tubes, to build a computer with a vacuum tube is a very hassle task, right? Because they are very huge and they're very large. So ultimately, rather than just going with the vacuum tubes, right, people started using transistors after the invention of the transistors, right? So after we have semiconductors, right? If you all are from BTech background, you might know transistors. You might have, read about them in your life in the past, right? So transistors are this three-legged device with an emitter, a conductor, and a base. And ultimately, this particular transistor can have two situations, or basically two things, two particular phases, we could say. So either it can be on or it can be off, right? So either it can be switched on or it can be switched off, right? And when they're used in computer, we know that when it is switched off, it's basically called as a zero, right? And if it's switched on, we basically count it as one. So that was the base of how these kind of things got started over here, right? So the base was transistors, and basically taking either you're having transistor as a switch on transistor or a switch off transistor, and that basically brought us to zeros and ones, right? So if the transistor is on, we can understand that yes, it is simply a one that is you can read, and that was the invention of binary language. So once we basically got a lot of transistors and we were basically able to get the transistors and everything, we can now understand, okay, these transistors are all good, but we need to make them work in a manner, right? So this is a whiteboard. So we want to make these transistors work in a certain manner, and we wanted to basically um, send certain data over here. So if I basically go around with this particular thing, right, it's something like, we can say that we can simply just basically go around with a certain thing, that a transistor can hold one bit of data, right? Either it can be a zero or it can be a one, but we need some combination of data. It's just like how you have cells in your body, and the group of cells is basically a tissue, and the group of tissues is a muscle, and the group of muscles is a system, and group of system is the whole body. So it's just like that, right? You need to basically hold a lot of other values to combine them and call them register, right? So you have like a lot of things over here, right? For example, a lot of bits, right? Because whenever you're sending data, you're sending the data in bulk, right? And what I mean by sending the data is that for example, you have this thing. Let's say you have a hard drive over here, right? Or let's say a floppy or anything that can store some data in a permanent form. So this is your storage device, right? So you have got basically your storage device over here. Now this storage device would have the data, right? And the data has to be processed by what? The data has to be processed by a CPU. So a CPU would be processing all the data, and your storage device would be the device that would be taking that data to the CPU. Now this particular storage device would be going over here, right? So the point is, how do I just take this data from the storage to CPU? Obviously, you will build a you will basically build a connection between them. Now, once you build a connection between them, you basically understand that the storage does not have that much speed, right? Your storage does not have that much speed, but CPU has a lot of speed, right? Even if you take today's example, right, your CPU can run at 3.5 gigahertz. Now that would basically mean that 3.5 gigahertz is like 35 million processes per second can be handled by my CPU. Now 3500 million processes is a huge number, but how many bits of data our storage could send? A storage can barely work maximum on 200 megabits per second, megabytes per second, right? So 100 mbps is not that higher speed, and that too I'm telling you of a very good hard disk, right? Even if you take a SSD over here, that would be around about 600 to 700 megabytes per second. Now that speed is not actually very much for the CPU, right? Because CPU is wasting its potential if it's not getting that much data, right? Because CPU can go for 3500 mega bytes of data, right? Why it's just getting 100 or 700, and then it's wasting all of its potential. So we needed something in the between, and this was basically the time when we basically got basically with this particular thing called as a RAM. So we basically invented RAM just because our CPU could have that much speed over here, and a new device was basically given over here, which is basically called as a RAM. Now RAM cannot store the data permanently because it is very speedy, and ultimately it is up to the mark, right? It is basically not equivalent to the speed of CPU, but it can basically go forward around with the CPU speed, right? So if your CPU can support 3.5 gigahertz, it would be running at 2.2, 2.5 something, and your RAM would basically can go around 2700 megahertz, right? So 2700 million processes per second can be transferred by my RAM to the CPU. So this would be fairly okayish, right? Because your CPU can take that much of data at just per second, and it would basically get that data. Now the point is that this particular data that we are transferring from a storage to RAM, and then RAM to CPU, back from CPU to RAM, and then back from RAM to disk, right, is done in a particular with format, right? It's basically done in a pipeline format. It's basically something like when you start a tap, right? When you start a tap, the tap basically takes all the water, right? And it takes a little bit of time, right, till the water would reach to the end of the pipe, right? It and depends upon the flow of water, obviously, and also depends upon the length of the pipe. The much lengthier your pipe is, right, the more time it would take, right? Also it depends upon how the girth, or basically the width of the pipe, the radius of the pipe is. So it basically is same over here. If I just make the cross section magnified, right, this particular thing, we're talking about this particular length, right? We're talking about the width over here. And usually when we started developing these things, these were like 8 sections out of it, right? So you can basically transfer 8 bits per unit of data that has been carried. So it's like 1, 2, 3, 4, 5, and then we got 6, 7, and 8, and ultimately these are sectioned like this. So obviously at one time you are sending 8 bits of data. So these 8 bits are basically taken through a transistor over here. So we have all the transistors weighted over here, and they're taking like 8 bits of data per amount of time, right? So that data can be anything. So you start with this and you basically end over here. So at each amount of time you're sending like 8, 8, 8, 8, 8. So you're basically sending 8 bits of data, then 8 bits of data, then 8 bits of data, just like that, right? So over here, if you're sending this 8 bits of data over here, let's say we are sending 1, 0, 0, 1, 1, 0, 1, 1. So you're basically making a number over here like 1, 0, 0, 1, 1, 0, 1, 1, right? So if your number is this 1, 0, 0, 1, 1, 0, 1, 1. Now the point is that this is a 8-bit number. What would you do with this particular number over here? That is very much needed, right? Now, how do I actually understand that what do I do with this particular number? Is that I want to understand about what I want to do. Let's say I want to do certain addition over here, right? So I want to do addition. So all my thing is basically I want to sum two numbers. So whenever you are adding, right, you might have basically created a program, right, about adding two numbers over here in particular C++ or Python. And what you do, you basically take in first number as an input, and then you take second number as the input, right? So when you have taken first number in the input, the first number gets stored in the RAM somewhere, and the second number is yet to come from the keyboard, right? So basically what happens with this particular data is that we basically try to characterize this particular data in formats, right? So we are having this particular thing where what we would do, we will divide this data into 3 segments, right? Where the first segment, the rightmost segment, will be the location, right? Will be the location of my first number, right? Location of the first number, right? In my RAM. So it would be basically the location of my first number in my RAM. So it would be basically in my RAM, what is the location of the first number. So the second might be what we can say the number that is directly coming from the keyboard. So this is the second number, right? So this is the second number that would be directly coming from the keyboard. And this is the operation code, or we can say op code, that what you want to do with this number, right? What you want to do, what is the operation you want to apply, right? So ultimately this is the second number, this is the first number, but the location of it, so you have to go at 0x011, and then you will be able to get that number from the RAM itself, right? So now this particular thing that is you know, giving you, or that is transferring this 8 bits of data from here to here, this particular 8 bits of you know, what I can say, the whole, this 8 bits cylinder, or not the cylinder, the container, this 8-bit container is actually a register, and this register can be called as a data register because it is bringing certain data over here, right? Or you can say information register. It is just bringing some information over here, and we will basically call it as IR, or information register. So from information register we can understand that this is the second number. So this second number, we will be having one more register over here. So let's basically create one more register over here, and let's call the register as DR, or data register. This would basically contain this 011. So 011 is contained by my second register, and let's basically create one more register over here that would take the location of this thing. Let's call this as address register, right? So there would be address register that would basically take 011, right? So now you have to go into this 011, and whatever you know, you would basically get the number you would get, you would have a new data register for it. Let's call it data register 1, and let's call it data register 2. So you would go to this location, you will get a number, and you will basically put it over here in data register 2. So now this particular thing is characterized, right? And the opcode, it might be a certain thing that what you want to do with it. So for example, 10 is the code for addition. Might be possible that 00 is the code for subtraction, and 01 is the code for division, right? Then you have like 10 is the code for addition, and 11 might be the code for multiplication. Now this is what your CPU already understands, right? This is what you have feeded in your CPU already, that if you get 10, you have to add those numbers, right? So basically we have given 10, and my CPU knows that, okay, these are the two numbers that I have to add, where this number is the actual number that I am getting from the keyboard, but this is the location. So you have to go into 011, and you have to basically get the number. So let's say in RAM, the original number was 101, right? So the original number was 101. So basically got 101 over here. Now we want to add these two numbers. So 011 and 101 will be added, right? Obviously in binary mathematics, right? If you add these numbers, this would basically go around like this. So again, so this would basically become 1000, or 8 in the decimal number system, right? You are just adding 5 and 3 together, so this would basically go with 8. So ultimately this particular number will then be loaded into directly the output register, which would basically you know, show this particular thing directly onto your screen. So the point of this whole explanation is, what are the registers, right? That is what I wanted you to understand, because registers are the basic building block of everything. Before going into the practical part of it, right, it is very necessary to understand the registers, right? Because if we do not understand registers, we won't be able to understand how actually these cracks are basically built, and how actually these things are there, right? This is just a simple explanation of what I did, right? We basically got two data registers, and one data register we are sending one part of information register. In second data register we are sending something that might come from the RAM. We are taking that particular address from the information register itself. Information register also gets the opcode, right? And because right now our architecture, our data bus, right, this particular thing can only take, you know, 8 bits of data at a particular amount of time, we can actually understand that we are having 8-bit architecture system, right? So we are basically having 8-bit architecture system rather than having a proper a big system. Right now, if I talk about our current scenario, we have 64-bit architecture system. So 64-bit of data is basically transferred from the RAM to CPU, and your CPU is good to go with that, right? Because if you have 64 bits, you're sending a good large amount of data at a time. Your opcode would be larger, that could support more operations at particular amount of time. So this basically gives a lot of flexibility, and that is why 64-bit software, 64-bit operating systems are much more better than a 32-bit operating system, right? And that is why the colors or the graphics of the video games are also differentiated, right? So if I show you 8-bit video games, right, these are certainly not that much good, right? You might have played 8-bit video games, like just like how I had it my presentation. It's basically like Mario and all these characters, right? Because in 8 bits you cannot transfer a lot of data at one amount of time, so you cannot draw a lot of graphics, right? So these are 8 bits, right? And if I basically go around with 16-bit video games, the video games like Final Fantasy, right? Final Fantasy 6, Final Fantasy 7, right? So these video games are basically 16-bit, right? More like Contra or something. So you get a little bit more color, a little bit more graphics, right? And then when you have 32-bit gaming, obviously you can play the games like San Andreas and all, right? So 32-bit games are much better over here. Why stop at 64? Why not move to? Because it is actually not viable, right? Even if you have 128, you won't be using 128. You would be using 64 because your softwares are not going above than 64, right? So if I create an operating system with a higher level thing, right, I need to have that hardware. So the hardware, people says that 64 is the optimum level. You do not need more than that, right? Other than that, in the phones you have 86-bit, right? That's why it's called as x86 architecture, right? So in mobile phones or in Raspberry Pi, in your TVs or something like that, you have 86 bits going on over there because you want to send a lot more data then. So that is how these things are working over there, right? So yeah, let's go forward and let's basically see certain practical aspect of this thing as well. So are you able to understand what I wanted to deliver with the this whole diagram thing and everything? Just give me a yes in the chats. If you're able to understand this, give me a yes in the chats, please. So this is a very basic building knowledge of everything, right? Cool, cool. Okay, so let's go forward and let's try to basically analyze the things, right? So if I basically I have Kali Linux over here in this particular thing, right? So this is just simple Kali Linux that I have loaded over here, right? And basically what I have over here is a simple Kali Linux that you can also download. It's not a hypervisor right now, but it's basically something what I can say is Windows 11 software, right? So I prefer to use the hypervisors like VMware or something like that, but usually when I go out, I do not have my own laptop. So on this laptop on Windows 11, it's better to use Kali over here because it's pretty much easier over here, right? It's pretty much easier when we use in Windows 11. So that is what you can use, right, as well, and this works pretty well. So over here I am having a pretty simple file over here that is called as crackme. And yes, this file you can also basically go ahead and use this particular file, which is directly coming from tryhackme only. So the lab that I've taken this file from is reversing ELF, so you can also practice. It has 7-8 files over there, so you can just take any particular file that you would want, right? So you would be able to use that particular thing, right? So the point is that we have what we have over here is this file. So if I just show you, this is a simple file. If I just show you this crackme, this is a pretty simple ELF file. Now what is the ELF? ELF is basically an executable that is used for Linux, right? So it's a Linux format for executable file, right? So there are two things, binaries and executables. Both are different, right? Binaries are basically those things which are having no as such meaning, and executables are basically the meaningful file on which you click and something happens, right? So if you click those files, some installation would happen, or something would get removed, or something would happen, right? So you know that when you click on certain these kind of files, something happens, right? Rather than that, ELF is a Linux based executable, and for Windows we have PE based executables. So all these DLL files and PE based, these are actually these are all Windows executables. And if I talk about this particular thing over here about ELF, this is a Linux based executable. So currently this particular file is 64-bit file, and it's generally like that, right? When you want to basically go around with a software, let's say you want to hack into a software or create a crack for the software, what would happen is that, let's talk about the software like VMware itself. Right now, VMware is a software that comes with offline activation, and a lot of games comes with offline activation, where you basically have the product key on a CD, or a product key is given directly to you. So the point is that when you download these softwares, right, you would basically need to put a product key, and when they ask you the product key and you don't have the product key, you won't be able to activate the product. The point is that how at that point, how will you be able to create a crack for it, right? And a lot of video games have this particular issue where you would want to create a crack for it, but you the point is, how do you do that? So it's pretty simple. You just have to load that particular file in a debugger or something like that, and you want to create a new exe for that particular thing, or a new executable for that thing, right? So there are two options. Either you can just go ahead and just simply bypass the if else condition over there, right? So to bypass the if else condition, you would need to understand the assembly language as well. Right now, what assembly language is? It's just a simple language where you are just doing the exchange of all the registers. So taking one register to the second register, this data of register would go to this data of register. So ultimately what we did in that example, IR to DR, DR to that AR, all of that thing you have to do in assembly over here. So once you're doing there, you would basically understand how these things are working. So the point is that assembly language is one of the main language that you need to understand. And in assembly language, there are multiple things going on, right? So in assembly, you would basically have a JZ, right, instruction, and this JZ instruction is basically the instruction where all the if else takes place. So whenever you have something like this, I do not have any exe as of now, or any executable as of now to show, but it's a pretty simple jump statement, which basically gives you a if else condition over here. So the first way is that wherever you are basically getting this if condition, where it is being, where your wrong product key is compared with the correct product key, you can just simply remove this J and Z, or convert this J and Z instruction to JZ instruction, and you are good to go, because now that instruction is changed and the if else would not work correctly. So even if you give the correct wrong product key, it would be accepted, because the flow of the code will go down without checking the if condition over there, right? So the if would always work, right, if you basically change from this JNZ to JZ. So these instructions are basically in assembly. One thing that you can do over here. Other thing that I would love more is basically to go forward. And for example, this is a file over here and it asks a password, right? So for example, if I just try to run this file, it would simply ask me the password over here. So let me try to give a password hello over here. So it would simply say that your password hello not okay, right? So if I give any password over here, if I run it without password, it would say we have used strcmp function, the string comparison function, and the string is actually the usage is not right, right? So the usage is you have to give a password over here. So if we get the password correctly, right, the program would work easily. And if we do not get the password, obviously it would simply say password hello, or password anything that you would give not okay, right? So if I give any password like my name, it would simply say no, this is not the correct password. So the point is, I want to give the correct password over here, or I want to understand what is the password, right? First thing is to brute force it, right? But I don't want to do brute force, right? Because it would take eternity for me to brute force this thing. The second thing, what I want to do is that I want to basically try to, go forward with, simply what I can say is that I can simply just go forward with any kind of debugger or something through which I can understand how the registers are working, right? Because when that particular thing would happen, what I want to see is that when this thing would happen, what the comparison of my file with the sorry, my password with the correct password, those two passwords that I give from the keyboard and the password that is already there would already there in this particular file would be directly taken down into two registers. And at that time, if I would read the value of those two registers, I would be able to get my password. Right. So let's go ahead, and for that I will simply be using GDB as of now. So I'll basically be going with GDB. So GDB is a simple debugger over here, right? So let me install GDB. So sudo install GDB. So let's basically try to install GDB. Let's see if it works or not. So what we want, missing destination, sudo apt install. Forgot the apt. Okay, let it work and let it install GDB. It's not a very big application, right? So just a simple 48 MB, right? So let's see if it gets installed or not. So, okay, so it's downloading. So GDB is a simple application that you can just simply download in your Kali. Make sure you have updated your Kali, or you can work on any Linux if you want to work on Ubuntu, if you want to work on any Debian based or Arch based other Linux, or any other kind of Linux, you can do that as well, right? So this can also be done on your Termux if you are on Android phone, or if you are on your Mac, so you can also do that over there. So GDB is a pretty simple debugger. What we would do, the premise of what we are going to do is that we would supply it a demo password, and we will basically see what is the instruction, or what is the the what is the actual destination of where this particular thing, the comparison takes place, and we'll just stop the program there. And once a program gets stopped, we'll look into the registers and we'll get the value of our passwords, right? So this is what we will be analyzing, right? So I'll show you how these things are actually analyzed and how these things are actually working over there. So let it just simply install. It have just downloaded the thing, and right now just installing the GDB over here. So let it just work, right? After that, after GDB, will also basically be seeing this through R2 or Radar 2, because Radar 2 would help me a little bit more over here, right? How? Because Radar 2 is also a kind of what we can say debugger, and it would show a lot more, right? It would show basically a lot more than what we can see in the GDB, right? So with GDB, we can get the passwords in just, what we can say, just 30 seconds if you know how to use it, right? And in R2, it's a much more complicated process. You need to analyze all the functions. You need to analyze all the things. So it would basically give you the assembly code of the functions. Let it work. I'll show you these things. And once we analyze this file, we'll be going forward into the usage of these registers, into the hacking of the games as well, right? So right now the perspective is to directly get the crack, to basically directly get the our exe working over there. The second thing is, if you already have a game, you want to create a you know uh, let's say a health pack for it, infinite health pack for it, or infinite ammo pack for it. How will you create that mod, right? So we'll be doing that as well. So let it just go over, and then we will be shifting to that thing. Yes, the recording would be shared. Okay, it's taking time. I guess on in Kali it generally don't takes a lot of time. It doesn't take a lot of time, but just because we are right now on our this WSL, Windows Subsystem for Linux, it might take a little bit of time. Let it be just a small application, right? So we'll be able to directly then run it. Meanwhile, if you have any doubts, we can just go around with it. Even if the password is hard coded, right, or even if it is not, right, the password has to go into that, um, that thing, into that register. If it's hard coded, we can just simply use the file command, or sorry, the strings command to basically get it, right? So we can just go around and try to do that, right? Once it's complete, it's not hard coded, right? We can just simply use our strings command and get all the hard coded strings. If we get it there, cool. If we do not get it there, we have to go through it, go through the GDB process. Do we are trying to hook into function, or do we need to reverse and analyze the assembly level for analyzing the code? We are actually going into the function. We are running the function in the real time in a sandbox environment, and we are just putting a breakpoint to it, right? That whenever the code runs, you have to stop it here. And once it stops, we'll be basically seeing inside the registers that in the real time, what is the value that my register holds, right? Or the variables would also hold. So that is what we are going to see. So GDB has been installed. Let's go and use GDB. Let's see if it works. Yes, it works, right? So we'll just exit as of now and give it a program. So GDB, and we'll give crackme, right? So crackme has been loaded over here, right? Pretty simple. And we can just simply go forward now. So here what I would do is that, because you can see crackme has been loaded, we would basically go around and check out the info of the functions. So info functions, and this would give me the name of all the functions that are there. So if you can see over here, we have these functions right over here, and ultimately these are the location of the functions, right, which would be going there in the RAM, right? So we have the init function from the start and finish function at the end, right? So you can actually see that from start to end we have all the things over here, and we are starting, our main function is basically there. It would basically call other function like compare password. Compare password would call get password function, and get password would might be calling strcmp function over here. So if we do not get strcmp, right, we are basically getting strcmp over here. Why? Because strcmp is a C++ based function called as string comparison. So yes, we will be having string comparison over here. So the point is that string comparison is the main it might be the main comparison, right? See, if it's in the real life, if you're using a real life executable, string comparison might hold the value, or might be actually comparing the two variables, right? But if you are used into a CTF, right, it might be possible that string comparison might not be doing that, right? This is the difference between the CTF challenge and the real life, because in real life, you know that the developer will be using strcmp, but in the CTF, you know that the developer might have used a rabbit hole instead of just using directly strcmp, and there might be some other function that the developer might have created. So you need to look into that basically. Right now, what we have got is strcmp over here, right? So this is a string comparison function. We'll look into it. If we do not get a password from here, we'll look into something else. But that is what I can go for now. So here we have our location, right? So I'll just copy the location and simply just set up a breakpoint on this location. So to set up a breakpoint on this location, I'll just simply do this, and I'll just simply go around like this. So if you basically go like this, it would simply set up a breakpoint over here, and we have set up a breakpoint at 400520. So our breakpoint has been set at this location, and when the program would run, it would stop at this strcmp. So if I basically run this particular thing, okay, I need to also give a dummy password. So for dummy password, I'll be giving hello123. So hello123 is my dummy password over here. It would run with this dummy password, and you can see once it runs with the dummy password, it would basically tell me that the breakpoint one has been hit. Now if the breakpoint one has been hit, right, we know that the program has stopped, right? And when the program has stopped, we can simply just go around and simply just info the registers. So let's just go go ahead and we can info our registers. So infoing the registers will be giving us the registers over here, right? So all the registers are loaded from this particular point to the end, right? So there are a lot of registers that we have got. And usually these are called as general purpose registers because these all hold data. So these are all data registers. And these data registers are actually having some general purpose data. So these are called as general purpose registers. And they are like named like this: RAX, RBX, RCX, RDX. Why they have names like this? It's a whole lot different story. We're not going in that, but you can just understand there are multiple registers with these names: RSI, RDI, RBP, RSP, then R10, R13, R11, like till R15. So the point is these are all different registers over here. Now RAX is basically right now located at this particular location in the RAM, and this is just the decimal form of that location. The point is that our password might be in RAX, might be in RBX. Basically, our password can be in any of the register in these eight, because these eight registers are general purpose and this only holds the variables. So ultimately, these registers, these data registers might have our password. So one of them might have it. So I have to do a little bit brute force over here, that which register might be having a thing. So we just have 8 values, so we can just go forward and try to print these 8 values. So first, let's take this DFF0 over here, right? So you can see one more thing, that RAX is having the same value as RDI. It's not the value but the location. RDI and RAX has the same location, right? Just analyze this thing, right? RAX and RDI are having same locations, and RSI and RDX are having same locations. So RDX value might be copied into RSI and RX value might be copied into RDI. So we can see that RDI contains the same value as RAX and RSI contains the same value as RDX. Now this might be done because there might be two variables, right? And the variables might be copied to other variables, right? For it, just like how you basically have variable one as the password variable, variable two as the input basically that you have given. Then you are copying those two variables into two other variables in a function. It's something like when you call a function, they are basically going into the parameters, but then you have two other you have created two other variables where you're copying those values for that local function itself. So this might have happened, right? We'll analyze this in R2, read R2, but right now we can just read this one, RAX, we can read RBX, we can read RDX, right? Rather all are same. And also we can read this particular thing, RBP. So let's see which one we could basically get our password from. So let's basically take this particular thing over here, copy it. Let's basically do x/s and give the our variable over here, or the location. So x/s is basically the syntax for this thing. So if I do this, we can get this string, my mode secure password. Now this can be our password, this might be our password. Let's try to read other registers as well. So if I try to read RBX over here, right? So let's basically go ahead, remove this and give RBX. It doesn't have anything, just a simple garbage data, or might be data used by the RAM. So not having anything. Let's try to read RCX, what it has. So x/s, and it's basically give this thing, cannot access memory location. So we are not able to basically access this location as of now. Let's try to read this 3EB, because some register would basically be having our hello 123 as well. Okay, so this one is having hello 123. So we can see that this 3EB is having hello 123. So this RDX is right now having hello 123, and it's being copied into RSI as well. And our password is with RAX, which will be copied in RDI as well. So might be possible that RDI and RSI are compared at the end to basically see which particular, if they are equal, go forward. If they're not equal, you have to just, show something else. You have to work. You have to just send the flow to the else condition, right? So that is what is happening over here, right? RSI, RDI might be comparing with each other. So we still do not know that, right? To analyze that, we can go much forward, much deeper. We'll go, right? But if it's just the sake of the password, so we have got the password over here, and that is how I used to get a lot of product keys as well, right? So we have got this particular thing. I can copy this, right? Exit from GDB, right? And what I can do is I can just run this crackme file once again and supply the password, and you can see that the password is okay. So this was the actual password, right? So now let's try to do it with uh, some other way over here. So we'll basically use R2. Now with R2, I would also basically need to, run my crackme file over here. So I'll just do -d because I want to decompile it or simply deconstruct it. And then I want to basically use my file over here. So crackme file, also I have to give the password. So hello123. Here I have to supply the password while we're loading the file itself. So R2 has started, and first of all we'll do AAA because we want to do the analyzation, right? If you want to analyze the flags, you can do AA. So AAA would basically give you the help menu as well, and it would also basically start analyzation, right? And ultimately this simple help menu that you might want to use for the analyzation, right? We want to analyze the functions, so we'll use AFL, right? So analyze the function list, and if I just press enter, it would analyze all the functions over here. So here we have got certain functions and basically the symlinks of that as well, right? And we have got certain functions over here. We have got the main function, we have got the strcmp function, we have got the compare password function, and here also we can see the same thing, that our strcmp is at 520, that we have already seen over here when we were using GDB. Our strcmp was at 520, right? So that is what we have basically got. Our registry value and environment value same. See, registry values, basically the values that are held by the registers are, it's for a very short amount of time. But environment values are different. They are like constant, right? So environment values are different than the register values. Register values are, the registers are holding data for a very temporary amount of time, and when the process executes, or when the process is basically done, right, it completes, all the registers are basically rewritten with some other values, right? Didn't we have to put the same password while deconstructing? No, we do not have to, right? We've just given the dummy password, right? We do not know the correct password. What we want to do is we have supplied it a password that when we would run the program, this password would be taken as a dummy password. So we have just given a dummy password because we are hacking now. We do not know the correct password. So we have given a dummy password over here, right? So now when we would basically go around with it, we'll understand that password would basically be loaded over here, right? So we got the main function over here. We got our strcmp function. So let's basically see what is happening in the main function, right? Let's go in the main function itself. So for that, I'll be using PDF. PDF is just print the definition of the function, right? So print the definition of the function, and then you have to basically give the name of the function over here. So to give the name of the function, we have to put an @ over here and space, right, @ and give the name of the function. So I want to know the main function, what it is doing, right? So I'll just simply put main. So once I have entered this PDF main, right, print the definition of the function, we have got the whole definition of the function over here. And in this definition, you can basically see that we have got the int main. It's taking argc and argv, right? Hope so you are equipped with the knowledge of argc and argv. We are just taking the input as the command line input. That's it, right? Where we know that argc would hold the data, argc would hold the number of arguments we are having, and argv would hold the actual data, right? So here in this case, if we are running this, we are having two arguments, crackme and hello123, and argv would here take this particular data in the double dimensional array, right? So over here we have this particular thing. It would show you all the variables. So all the variables that you can see with this var are all the variables that are used in this function. So there are two variables, var4h and var10h, right? So ultimately we have got all the variables over here. So this 10h is being used over here, 4h is used over here, and you can see that we are calling the compare password function. So in the main function, we are calling the compare password function. So let's basically go in the compare password function, right? So let's go over there and simply use pdf at the rate, and then we have to copy the complete name of the function, right, and paste it over here. So I'll just press enter, and simply I will be able to go inside the function. Now this function is having a lot more variables, right? There are like 1 2 3 4 5 6 variables over here, right? And in this 6 variables, what we are having is, this is the point we are doing string comparison. So before string comparison, if you basically see, we are having these instructions, right? Now, this is where it explains the analyzation that we did in the GDB. In GDB, you might have seen that RSI had the same value as RDX, RDI had the same value as RAX. Can you see that a move instruction has been used? So a move instruction basically copies the data of this register into this register. So that is why RDX was similar to RSI and RAX had the same location as RDI, because they are actually copied into each other, and that is what we can say. And you can see where this RDX is coming from. It's coming from variable 20h, and this RAX is coming from variable 28h, right? So it's written keyword, it's typecasted basically. So keyword is basically a quant word. It's basically taking might be taking larger amount of data. That is why, right? So do not go with this, right? It's just a simple thing. Keyword, d word, these are just the sizes. All right. So it's just like end and signed in, and then you had the float option, float, and all these kind of things, right? So it's just a simple typecasting. But variable 28h and variable 20h, these are the variables which are actually taking my variables, which are actually taking my data. One of these would be having the correct password. One of this would be having hello123. But right now, if I try to basically go over, and if I try to basically run this particular thing over here, I can just run this particular function through DC, right? So the whole function, sorry, the whole code, sorry, would basically run with DC, right? So I have run DC over here, and it would simply say hello123 not okay, process exited. Pretty simple. Why? It's a pretty simple mistake that I have done right now. I have not set the breakpoint. So because I didn't set the breakpoint, it would execute the function, or it would execute the code as it is, right? So the point is, I need to set a breakpoint because I want to stop at some location. So let's stop at this location, right? Let's try to stop at this CF, right? So that I can see the variables. Right. If you stop at D5, right, you can look into RDI, RX, RSI, RDX. We have already done that in GDB. This time we'll try to look into the variables, right? Variables that are stored in the memory, which are basically given to the registers. So the point is that I would try to stop it in this point at CF. So over here, I would basically copy this location as of now, and I would basically go around with DB. So now DB is basically what we call as our, what we can basically say. It's a simple breakpoint, how to set a breakpoint. So press enter, the breakpoint has been set. We'll type DC once again, and the process terminates, right? Should not terminate, we'll do DC once again, cannot continue. We do not want to run OOD. Okay, so I guess it's not stopping at that point. So let's see what we can do. We can try any other format, right? So let's try to do and stop at this point. So we can try, use a new breakpoint over here, and no such file or directory cannot open. Once again, breakpoint has been set, cannot set breakpoint. Okay, we are not able to set the breakpoint. I guess it's not loaded properly. Let's try to go back and try to load this file once again. Sometimes it gets corrupt and does not set anything, but we can do that once again. So AFL, we already know everything about it, right? It has analyzed things. We can directly go forward to this thing, right? 6D2, right? As we know that the breakpoint has been set. DC, you can see the breakpoint has been hit. So this is actually the format which we wanted to do. And now because everything has been everything is in the position, we can just simply try to print the variables and print the things. So to print everything, we can use PX, right? So let me do a PDF over here. Pretty cool, pretty quick. So PDF compare password, right? You can see over here. Right now we have already been stopped at this 6D2. You can see it's highlighted now because we are already stopped over there. B is given over here. That means we are having a breakpoint on this. And right now we have all the variables, right? So we are having 20H and 28H. We can see the variable. So the variable 28H is called as @RBP0x28 and 20H is called this. So we'll just copy this, right? And to print, the command is px over here, right? So if I just go like this, it would print the value of x28, which is my more secure password, right? So if you want to read x20h as well, so it's called as x20. So here is again my more secure password is again basically over there. So both the variables are basically having the same passwords as of now, right? If I stop at this point, don't know why, but it has that, right? So basically 20h 28h has both the same passwords. And what if I try to read RSI RDX? Let's try to RSI RDX would be same, right? So let's try to read RSI and RDI, right? Let's try to read the value of RSI RDI. So to read RSI RDI, it's pretty simple. I can just simply go ahead with RSI over here, and RSI has this hello 123, right? And RDI would basically have our correct password. So our RDI has the correct password, and our RSI is having hello 123 with a lot of other options as well, that where it is located and all. It has like a lot of meta information of that file as well. So this is what we have got from there. So this is how you analyze it, right? You might get into some mistakes, sometimes it gets corrupted, but this is actually how you are analyzing it in the industry level as well, or whenever you want to see a password from this, right? So usually whenever you're going into a software like VMware or a Windows machine or something like that, the setup crack sorry, to create the crack, the setup of that file, that main exe of that file is the file where you will be able to get the thing. So if you have Windows, right, you can just simply go through the main exe of that Windows. Whenever you install that file, you would see that the data files would obviously be huge, but the main exe file would be always in KB. It would be either in 7 KB, 10 KB, 12 KB, 13 KB, or something like that. Or even if you basically use a game or anything, or you take a game or anything, you would see that the main exe file would obviously be smaller in size. So what you have to do, you have to simply just go over and open that exe file in a debugger like this. So if I know that for Windows you would ask me that, so what kind of debugger I can use for Windows, because this is for Linux, right? GDB and all can be used in Linux, and Windows is different. So I have created a GitHub repository of mine that is public, and that is basically for meetups and all the stuff. So whenever I go to meetups, all my presentations and all are shared in this meetups PPT. So on my GitHub, you will be able to see in this meetups PPT, and besides Mumbai, because in this conference I've given this talk of game hacking, right? So here you can basically go into the tools and download this tool over here. So the tool is Win32DBG, and this debugger can be used for your Windows. Not only it can just simply try to manipulate, if you want to manipulate the assembly code, or if you want to manipulate this particular thing, see the passwords, it can do all those stuff graphically as well. But if you want to basically manipulate and create a new exe file, you can do that over here with this. So you can create a new exe file with this, and pretty simple. You can just once you have created a new exe file, you just have to replace the old one with the new exe, and boom, your game would not ask for the passwords again, right? So you can do that with this Windows-based debugger, and that is what we have. Then we also have Cheat Engine that I'll be using for the game engine as of now, right? So that is the point, right? So did you understand what we did over here? What is the analyzation part that we did? If you understood, please type in with a yes in the chats. For how many games I've cracked passwords, Sonu, I have gone through with a lot of games in the past, like Assassin's Creed and all. I've done it for. I do not go for the game hacking part, like license hacking part, right now, because in the modern games they have a lot of, this what we call as this DMCs and a lot of other kind of security frameworks are there, right? So it takes a lot of time to bypass those security frameworks because there are like a lot of files, a lot of DLL files, a lot of other files are directly having that DRM de novo, these kind of things, right? So these de novo things and DRM things, they are actually stored in like a simple line of it, or basically the connection of these things are actually stored in a lot of what we can say files in the games, right? So you have to basically go around, open all the files, and then break the connection with de novo in the assembly code. You have to just then redo that file by making the file, by exporting the file once again, and then you have to see if that game works or not. So it's a lot of hit and trial. So when a lot of this DRM de novo things are coming, I stopped this game hacking and all. Mostly I focus on creating the mods of it. But in the past, when I used to do this, I used to create the cracks for Assassin's Creed. I did till Assassin's Creed 4, till Unity. Yeah, I created it one for Unity as well. I did it for GTA, obviously, till GTA 4, not for 5. For 5, I have created mods, right? And a lot of other like Uncharted and a lot of like RDR and Watch Dogs and all these games as well. And some applications like Adobe. You might have seen that in the previous versions of Adobe, there was that amtlib.dll, which is actually the one you need to replace, and your these things would work. Adobe softwares, and this used to happen till Adobe 2022. After that, they started with some other things, and there are a lot of other files that you would need, right? I might have that PPT over here. Let's see. The tab has been closed. Yeah, so I might have that. I don't know if I have uploaded that PPT over here or not, but there is one PPT which would have the screenshots of the current Adobe based softwares. No, I don't think I have it over here. No. So basically, that PPT basically had I'll share it over here, right? So I basically went through all the DLLs, found all the DLLs, and found all the files in current Adobe based applications, and you just have to modify those, and you will be able to go forward with the cracks of that. So I've created all those things, right, and worked in that. Okay, so were you successful making your own cheat code in GTA San Andreas? Yes, I was successful. And for that, I needed to work around with the C hash format as well. Needed to work with the renderware game engine as well. And that took a lot of work over there, because a lot of times the game got crashed, and you need to basically make it support for Clio, because Clio is the main script loader for San Andreas. So I had to basically make it for Clio. Other than Clio, if I were making it for to directly work with the game, it didn't load the game. I didn't load the script because of obvious, I guess, reasons. The reason was it was checking the file hash, that the file does not belong to the game, so it would not load that. But Clio, because it was made officially for the game, Rockstar confirms that. So uh, that's how I was able to run my script. But I had to go and write certain things in C hash as well. Okay, if I'm not wrong, it is similar to Android pen testing. Like Android pen testing is a different thing, right? Whenever you're working with Android pen testing, the reverse engineering process is through this thing, that Android software that comes over there. It's a jar file. So you basically use that Android debugger, and through that you basically, when you basically open that Android APK file, you get a lot of files in which you try to obfuscate into the code or basically check the codes. The analyzation part is different because here you are going with the analyzation of assembly, and there you are going with the analyzation of Java files, right? So the analyzation is a little bit different, and there are certain differences in Android pen testing. Also, in Android pen testing, you need to basically look for web-based vulnerabilities as well, the OWASP top 10 of Android. But here it's not very much wide, right? So that is the thing. Any resource where we can learn from beginning, as I'm beginning. The first thing that you need to learn, Sono, is to go around with the assembly language. And once you are done with the assembly language, you have to basically work around with the registers. So there's one pretty good book that I could recommend, is this architecture book by Morris Mano, right? So Morris Mano is the person, and this book is actually used in colleges for computer system architecture. So from the chapter number 3 to chapter number 12, the book is really good with architecture and the flows. So it's a little bit old book, but old is gold. It's a very good gem, and you actually understand a lot of things, right, by reading the content in the book. So try reading Morris Mano, and while you are reading that book, go around with assembly language as much as you can, right? So if you work with assembly, you will be able to understand how actually the registers are working, and then you can go around with a lot of try hack me labs, which are basically for reverse engineering, right? Okay, moving forward with the game hacking part. So here I will be taking certain things over here. So there's this particular game that I have as of now called as Assault Cube. So Assault Cube is basically one of the game that uh, has a lot of things, right? Because I cannot take any other games as of now, right? Valorant or something like this. Sorry, because again the DRM or these kind of security frameworks would come into play, right? So I'll be taking Assault Cube as of now. So Assault Cube is one of the game which is exactly similar to these shooting games and FPS games, and we can take the things, right? So if you just remove this framework, security framework from the game, right, you will be able to mod these particular games just like how I will do in Assault Cube. It all works over there, and these kind of modifications would also work for CS Go. For CS2, they have introduced this Valve thing over here. So that is why it's a little bit different in CSGO. Just a sec, let me configure the game. Okay, I'm not able to bring the game to the second screen. Just a sec. Yeah, Valve anti-cheat I was talking about. Pony Island 3 is good. Pony Island 3, Pony Island 2, both are basically based on different games which you can use for hacking and learning the game hacking process. Okay, the game is loading. Once again, let it load. I'll just bring the game to this. In the meantime, you can just use the resources screen that is there, right? So it has a lot of reverse engineering challenges that you can learn. Okay, so let me go again. Disable the sound first of all, and simply do the setting. Okay, so we have got not getting the windowed mode in the game. Just a sec. Give me 2-3 minutes. Till the time you can just ask your doubts, I'll just answer that.
Yeah, Sanjay, I think Dhruv has asked like we should have a
Okay,
good.
so this is the
Yeah.
game over here that you can see right on the screen as of now. And let me just go forward with the game. So I'll just simply go with a single player and let's go with an empty map. Okay, so this is our game over here and it's pretty simple. It's just like how you have the game over here in the normal. Let me just go around. So we have this particular game over here that you can see, and it's a pretty simple game, right? That has everything like how a first-person shooter game would have, and it basically works really fine over here. So what I'm right now searching for is this particular thing over here, this grenade, right? Why I would need this, you will just see in a second. So in the meantime, I've loaded the game. I'll also be loading the cheat engine over here, like so this cheat engine over here is something like this. Let me just see. Okay, I just loaded cheat engine and the game got crashed. Okay, let me try to run the game once again. This is what cheat engine would look like. So cheat engine is a simple thing where I can just go around and open any application that might be working right now. So say alt cube is over here. I'll just take this particular application as of now and I'll basically work on with it, right? So let me just, the game is asking the dimensions again and again. So basically, we'll just take this game into account and all of the location variables of this particular game will be loaded over here. So we have got a all cube, as you can see, not responding as of now. Don't know what is happening. So okay, it's again crashed. No issues. We'll still basically go ahead and try one last time. If it works, cool. If it doesn't work, we'll take some other game. Okay, so you've got the game over here. Again, let's load a single player and let's go to empty map, AC Africa, and yeah, we have got a game working again. And this time we would have our cheat engine over here. So let's keep the cheat engine over here, game over here, and let's basically put the cheat engine right here. So over here, we'll just use our game over here. So this is Assault Cube. So if I just select Assault Cube as well, what would happen that it would load everything from Assault Cube, right? So it would load all the variables from the Assault Cube over here. And I would not simply just bore you with that particular thing that, okay, I'll just scan the values over here and simply I would be able to get all the things directly. But let's just spice up the things a little bit and let's see what we could basically get from here. So let's say that, just a simple example, I want to create a modification or I want to create a unlimited health mod for this game. So if I want to do that, you can see that right now my health is 100. First of all, I need to see that which variable actually I want to look for, which variable is actually holding the health of my particular player. Right now, what would happen in games like this to manage the efficiency or to manage the things over here, the health variable is dynamically loaded. For example, in my laptop the health variable would be different and your laptop the health would be pretty much different. So what I want to do, if I want to create a modification for this, I want to find the health variable which is actually same for both the for all the universal it should be basically universal variable. So the point is that health variable is different for me, health variable is different for you when you install the game in your PC. We want to understand that this health variable would be different, but the player object variable, the player which is holding the gun and whose health I'm talking about, a variable of this player would might be same for all of us, would might be universal for all of us, and that might be referencing to the health, right? So your player object variable would be referencing to the health variable, right? And there would be a lot of references that how many ammo of primary weapon this person has, how many or how much ammo of the secondary weapon this person has, how much health of this person is right now. So everything would be there, everything would be referenced over there. We need to find that address which might be constant in the game. So if we do not get that constant or the static variable, we would not be able to create the mod, right? Because you cannot create a mod for your own dynamic variable, right? For the other person it would not work, right? You need to find a static variable. So that is what we would need to do with the registers over here. So for that, I need to basically look for the health bar as of now, that is 100, and I need to look for a way in the game to decrease my health so that I can actually understand what register is actually holding the value of health right now in my PC. So let's basically go forward and do that, right? So I just simply go around with it and search for 100, right, as of now, because this is the current health. And we can see a lot of variables are given to me. So a lot of variables are simply given to me, which are having 100 health over here, right? And this one is also changing. This is dynamic. All the green ones are static ones, right? So all the green ones are static ones and all the white ones are dynamic ones. So I will be basically taking not taking any of these variables as of now. I cannot trust them because 100 might be 100 is a pretty simple value, right? It can be anything. So I need to make sure that I'm talking about health variable only. So I'll just go around and decrease my health, right, so that I can understand. For that, I would be needing a grenade. So here is a grenade over here. Let's pick up the grenade, right, and send a grenade. And let's try to decrease the health. Didn't work. Let's try once again. So let's take the grenade, throw it over there. So now my health is 72, right? You can see that I have decreased my health as of now. And I'll basically just simply do a new scan with 72 over here. So just do the next scan and we see that these two are the main variables, which has basically 72 over here. So I'll take both the variables, bring them down, and one by one try to change the value to see which variable is the main variable. So over here, if I just change it to 1000, in the game it didn't affect anything. It didn't do in the game anything. So we are still left with 72. This is not the correct variable. Let's delete this variable. Right. Let's take the other variable. This might be the variable, obviously, because we are only having one now. So 1000, and you can see the health is changed. So now I can change the health for myself. This is the address of the variable or of that register, which is holding my register value. So what I want to do with this thing is that I want to find a static variable, because this is a dynamic variable. You can see it's white, it's not green. So this is a dynamic variable, and this would only be used in my PC. Even if it is actually possible that if I just shut down my laptop, close it once, close on, switch on once again, and try to pick up this variable would be different, right? Because this is a dynamic variable, this would change. The point is I want to find a static one, right? Then only I will be able to create a universal modification for it, right? For now, I can create it for myself, but not for any other person. So for that, I'll basically right click over here and see, find out what writes to this address, that which is that particular incidence, or which is that particular address which is writing to this address. So that address might be a static address, or might be something like that. So we want to find out that particular thing, right? So usually it works 99% of the times. So just go ahead and click on find out what writes to this address. Sometimes you also need to go ahead what accesses this address, because sometimes it does not write, it accesses that. You are accessing what is the health of this person right now. If you're writing health, then you need to basically check on what writes to this. But if you're using that variable, then you have to go around with what assesses or what accesses this address. So right now I'll be going on to what writes, because we are changing the health, so we might be writing onto this variable. So if I click on this thing, it would open a debugger once again, and the debugger is this. So it would show the information once we are able to simply go forward, and once we are able to simply just decrease the health once again. Let's go around and decrease the health once again. So let's take this particular thing, and so the health is changed, and as soon as the health is changed, we have got 964 health remaining. And on the other hand, we have got our instruction. So in the instruction, we will basically go with the more information. We can close the debugger. This is the main thing that we need. Let's put it over here. And in this particular thing, you can see what we have got. We have got something, a move instruction, and we're moving the value of EAX into EDX plus EC as the offset. So we are taking EC as the offset, might be the new health, and EDX might be taking this A3FF24, basically the local address of my register, and EX might be the any other variable which might be giving us the value, right? So we are writing EAX into EDX, right? Okay, so we have a question from Dhruv. Can we hack by any other software or cheat engine? No, you can do it by any other thing as well, right? There are many softwares that are there, and cheat engine is by far the most easiest and most equipped software that you can say in today's time. Otherwise, there are like other softwares as well. For example, heap hack, or you can just read this particular variables through any other kind of things as well. There are multiple other softwares that can basically be used to get the variables over there, right? So I'll share a QR code as well for game hacking. So if you go into that resources, you'll find a lot of tools, right, that you can use for these kind of things, right? So we have got EX over here, right, and ultimately EDX. So EDX is the main thing, because you are adding something in the EDX right now. So EC might be the new health that we are having. I mean, 964 could be anything, but EDX is the main thing. So EDX is 0083FE38, right? So we are adding something to this address, 83FE38. So let's search for this value. Let's see what is written or what is there on this particular value. So I'll basically do a new scan, I'll search for a hex, and the hex I would search for is the EDX location. So the location is 83, right? FE, right? So let's keep it capital FE and then 38. So this is what we have. So I'll just simply go around with enter and we'll get the values over here, right? So we'll basically get the values over here. And over here, you can basically see that we have got 4 static variables. Now these static variables might be a player object variable, because this one is not player object variable. This is dynamic health, right? So let's name it dynamic health so that we can understand and do not forget, right? So this is our dynamic health variable. And out of these 4, any of these variable would be a static variable, right? Obviously all are static ones because these are green, but uh, any one of this or all of this could basically be going over to or pointing over to the player object variable. So let's take the last one. If it doesn't work, we can take any other one, third one, second one, first one, because I've done it a lot of times. I know that the last one is the main one. So if I basically go around with this thing, right, I'll just tell you how to check if this is the one or not, right? So I'll just take this down. We have got this particular thing over here, 595404, right? What we will do, we will go ahead to verify that it is the player object variable or not. We'll basically add address manually. So once we are adding the address manually, we would be getting this pop-up. Now in this pop-up, I would be simply typing my pointer value over here, right? So I will be basically giving my pointer value at this value. So this is 595404. So let's give it 595404. And we are adding what? So this is the value of EDX, right? We went into EDX, we got this 595404. So we are basically adding what? EC into it, right? So if we add EC into it, we would get our new health. So let's basically write EC, and this equals to 964, which is the new health. So that means this is the player object variable, right? So you can also do like, you can take this one as well. You can see the address and use that address over here, write that address over here, add EC into it. If it basically gives you the new health, you know that that is the player object variable. So it is subjective, right? For you, it could be something else. For me, it could be something else, right? Because obviously, these are not the dynamic ones. So for you, it might be possible that this static variable would work or this would work. But if I talk about a game universally, only one would be the same that would work, right? So for right now, we have this one, right? 195. Whatever it is, like it is 595404. This is basically the one that works, right? So if I would have taken this 18AC00, might be possible that this should not have worked, right? So we can do that as well. We can take this one over here, and this is basically 58AC00. So we can add address manually once again and try to do it once again. So 58, right? 58AC00. And if we try to add, this EC into it, we should basically be getting 964. So again, we are getting 964 over here. So that means we can take either of these two variables. These two variables are player object variables. You can just try this with the third one as well, fourth one as well, right? And you can create a mod with any one of these, right? If it gives you the correct value, that means you can create a mod with it, right? So we know let's take the previous one only, right? So we can delete this one, and this, because now we know that it's a player object variable, we can just simply put it over here, player object variable, right? That's it. Now this is our player object variable, and we know that now I need to find the static health variable as well. So to do that, we have this thing. We can right click over here and we can just go ahead with the disassemble memory region. We want to basically disassemble all the memory region that is used by this variable, right? So we'll just basically go around with this, and here in the tools there are a lot of options. You can also inject a DLL over here. DLL injection is also one of the game hacking method, but for now I'll be going into dissect the data structures. I want to dissect all the data and all the data structure it might be creating in the memory, right? So I'll do that. and here I need to write my value. So it was 595404. So 595404, right? And then go into structures and define new structure, right? So here I will basically get all the data structure. Now in the first one, it is 595404. We'll get all this pointers over here. So you can close this one. We have this. So we have like all the pointers it is being referenced to, right? And you can see right now I have 20 bullets, right? So we have like 19, 18 bullets, 17 bullets as of now. So there might be some variable in this which might be holding 17 as the value. So if I go just down, 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 let's see if we can get 17 here. We can get 17 over here. What if I try to change this 17 into 1700, right? So boom, you can see it changes, right? So this 1700 actually changes over here. So we can see that. Also, currently our health is 964. So we can also basically go around with 964. This is the value. I can right click and add this element, right? Not add, but I want to just add to address list. Yes. So the address list is updated with this. Also, let's write the 1700. This is my primary weapon ammo. We know that, right? Let's also see the secondary weapon ammo. It's 10, 9, 8. So 7, right? And we have seen this. This is the one, right? This is changing over here. So let's also basically go around and add to address list, right? So we know that this 964 is basically a static health, right? Static health over here, right? This one is our primary ammo, right? And this one is our secondary ammo. And all these are basically static ones, right? Which would not change even in your laptop. So I can now remove this dynamic health. I can delete this one. And over here, this is the main variable. So I can just change this, for example, 9,000, and the health would basically change to 9,000, right? I can change my ammo. I can change the 17 to 90, and my secondary ammo would change over here. So I can do that over here. And simply if I want to create a modification file for this, right? A mod for this, I'll create a simple bat file or a simple CMD file or an exe file, right? And I can simply write a simple code that as soon as you are opening that thing, I'll write a while true loop over here. What I would do, I would basically write a while true loop, and that while true loop would simply work for me, right? So that while true loop is the main loop, and in that loop what I would basically do, I would simply just go forward and I would just simply write something like this. Let me bring Sublime. So it would be something like a while true, right? So while true, that means that it is always running, and here I would write the value of my thing over here. So I'll basically take this and close this as well. So we can take this static health, right? And we can just use this particular thing over here, 595404, right? Or I can just take this particular thing, because 595404 is actually just simply referencing that particular thing. So our 595404 pointing towards this particular variable 0083ff. So it's 83ff24, 83ff24. So I'll be basically doing that this particular memory instruction, this particular memory region, or this particular variable that is, or this particular pointer that I would be creating over here, because I can create any pointer over here. I can create an int pointer over here, right? So int pointer, let's say p, and I can just reference to this particular memory address as of now with my hand symbol. And with this particular thing, I can basically go over and simply try to just put the value of it, right? So now I can just use the value of p as, as 1000. So what would happen that whenever I'm running this particular thing, what would happen that this memory instruction, obviously the syntax might be a little bit wrong, right? I've used the syntax of C language, right? So you can just simply work like this, and you can just simply give this particular instruction like this, and you are basically changing it to 1000 every time. So what would happen that your this particular memory instruction would change to 1000 every moment of time. So even if your health decreases, it would be 1000. So when your health decreases, or when you get a headshot of more than 1000, then only you will be able to die, right? So you have to basically measure it with whatever you want to, whatever damage, maximum damage your game would have. So for example, the maximum damage of your grenade is 500. So you have to keep it 500, 600 overall, because ultimately then you will survive. You're left with 100, right? And then the next moment your health will become 1000, right? So just in case, if I just keep it 200 as of now, what would happen if my grenade damage is 500, right? What would happen that I'll die. Even if I have a mod running, I'll die, right? Because 500 is the maximum damage and you will be getting healed to 200 only. So minus 300 you will die, right? So you need to basically adjust it with the maximum damage in your game, and your mod should always be having higher level of damage than the maximum damage allowed in the game, right? And with that particular thing, you will be able to create a mod, because if this particular loop is running every time, the moment you open the mod or switch on this particular mod, you will become invincible, right? Because you will not die, right? So that is how you can create mods over here, right? And yeah, you can change it to anything you want, but make sure you do not go off limits, right? Because if your game does not allow to go over 10,000, go over 20,000, there's a limit. There's a limit in the game, right? You can try. There would be one number ahead of which, if you go, the game would crash, right? So make sure to, and check that scenario as well. This usually happens because of the data structure the game might have taken. So if the game might have taken integer, you cannot go higher than a certain limit, right? If the game is taking a small data structure, again, you would be having a limit for that. So make sure whatever the limit is, you need to go forward with that. And obviously, you would be having the you would be having that limit through which you can basically create a mod, right? Obviously, in every game, right? Because developers cannot control the size of data structures. Even if they can, um, there would be a lot of scenarios where a game would need to have a higher level of damage, right? So in that case, you need to cater all the scenarios and everything. So because in many of the cutscenes, you might see that your player is jumping from a very high ground and he's not dying because it's just a cutscene. But that cutscene is also part of game, and for that cutscene, your damage has to be increased, right? And you need to have higher limits of the health, right? So in the background, the player basically would get higher health limit and would not die. So those are not actually videos that are shooted. Those are actually just the games having the higher limits. So that is why a game would obviously be having higher limits. So just make sure you do not go as much higher as it would crash the game, right? That is the thing. This is just a simple example of how the game's modifications can be created and how these things can be, worked upon, right? So we have the resources over here, right? These are reverse engineering resources. Let me just go around with there's one more PPT over here that might be having one more resources over here. Let me go around with my GitHub, right? And I'll show you that. So it will also basically give you the resources for game hacking as well. So that's how you can basically practice those things. So let's download the raw file. Okay, in the meantime, we are loading the resources. Let's read certain questions that I missed. So do we trying to achieve license key or mod or to find vulnerability or all? We are trying to do all basically. If you would basically want to do certain thing like go into the mod or create a mod, we can do that. If you want to find a vulnerability, we can do that, right? So depends upon whatever the situation is. Okay, so these are the resources. So for reverse engineering challenges, you can go around with this, the same QR code. And for game hacking resources, please scan this particular thing over here, right? I'm just stopping over here for a while so that you can click a screenshot. You can scan afterwards. How does VAC that work in user mode and here Rockstar requires kernel access? See, VACs that are running right now, they basically directly embed into your driver. So they basically become a driver, and once they become a driver, they would run as a driver. But the point is that because driver can do all the things, right? Whenever you want to, let's say, create a wall hack or something like that, how you can do that, you can just simply create a pretty simple wall hack by just telling your graphic engine, or by just telling your graphic driver that to create outline around the people, right, around the players in the game. The point is that you are not hacking into a game, you are just manipulating your driver, graphic driver, and graphic driver is yours. So that is why what these companies are doing, game companies, they are implementing driver level things, so that even if you manipulate your graphic driver, they would understand and they would directly ban you from the games, right? So and these drivers should only work whenever you open the game. But in the case of Valorant, the drivers are even working whenever you're not playing the game. So that is a little bit of concern because a driver can see everything. So that is the thing. So basically, for reverse engineering, we should have good knowledge of assembly. Oh yes, obviously. LOCs versus registers. So LOCs, can you give me the full form of that? Not able to quite remember that. If you give me the full form, I'll try to basically answer the question. Is there any YouTube channel which you can suggest where we can learn assembly language other than the books which you suggested? I have not seen a lot of YouTube channels which can, go through with a lot of assembly languages. It's just that I learned it through practicing, and the best part to learn any language is basically through building that thing or to practice that thing. So I would just recommend you to practice or build certain like addition, subtraction programs over there in assembly, and that's how you just learn there, right? You can take the help of ChatGPT rather than just going onto YouTube, right? Because if you go onto YouTube now, it would be a learning hell. You would see a lot of videos and you would basically see, okay, this, that, and you would not be able to understand the things, right? So better to learn by building, right? Okay. To learn game hacking or reverse engineering, first we have to learn assembly and registers. Yes, yes. So no. Gidra setup tips, beginner plugin recommendation, maybe Gidra setup tutorial video. For this, you can go to YouTube. YouTube has a lot of videos on Gidra setup, and see, when I use Gidra, I do not use any kind of plugin, right? It's bare simple thing over there, right? And you need plugins for Gidra when you're working in ELF, right? I usually work in PE based executables, portable executable of Windows. So I have not used yet, right? It's been 3 years, 4 years. I have not used any kind of plugin over there. So Gidra is capable of giving you all the values and everything, and its analyzers are everything that you need. So just analyze the functions automatically. It has all the options, and then you can just get the C code of it and just try to understand with the flow. Once you understand the flow, you will be able to go through with it. For the tutorial videos, I would suggest just go through the basic videos that are there on YouTube. Would be able to go forward with it. How different is it to change these health and ammo values for an online game? See, for an online game, it doesn't matter. The method would remain the same. But as soon as you change the particular value of the health, what would happen is that the server would communicate, and the server would say, okay, this is not the actual value. And based on that behavior, the server can do two things: either change the value to the same value, whatever it was, or just go through and ban you in the game as well. So make sure if you do it for online, it can also ban you, right? So in my laptop, my personal laptop I'm talking about, not the work laptop. In my personal laptop, I cannot play CS:GO. I cannot play Valorant. I cannot play um, GT Online because of these issues. I have tried creating mods for that. I've tried creating wall hacks for them, and they have banned me. Like Mac banned. So even if I try to create a new ID, that ID gets banned second day. Okay, so can you give us a roadmap to learn game hacking? This resources has a lot of things, right? So Sonu, just to go around with this, we do not need any kind of other resource. I have compiled all my resources in this QR code, right? YouTube recommendations. CryptoCat is good, but Live Overflow will be helpful when you really want to go around with buffer overflow attacks and when you really want to understand about the vulnerabilities. And the core vulnerabilities, basically the core vulnerabilities to get the reverse shell access. So live also is that. For basic cybersecurity and for all the other cybersecurity aspect, we have a lot of channels like this Insider PhD for bug hunting, Stoke for bug hunting, Nahamsec for bug hunting. You have Hackersploit for the core red teaming, blue teaming stuff. You have Network Chuck for the networking and Linux based videos. So these people are really good. Also, Computer File is good for all the cryptography and algorithm based stuff, right? DRM and de novo. See, DRM and de novo are basically placed as a higher level or a upper level security layer, which would not allow you to run any kind of third party script for that. Now, the point is that once you break into DRM and de novo, you get the clean files of the game, and this is the main task, to get the clean files of the game, because once you get the clean file of the games, you will be able to modify those things and do whatever you want with that. But directly getting, just breaking the de novo and DRM, right, is the main aspect of it, because it's what it is that de novo is a simple code that is running in the background and checking that you are not doing anything wrong. And also it takes CPU, that's why it also decreases your frames per second. FPS would be decreased in a typical game which is taking higher level of resources. It would decrease around 20 to 25 FPS easily, right? So the point is that usually de novo would work in a manner that there are a lot of files in the game which would interact with de novo with every aspect of time, and it would basically see, okay, that we are that okay, has not patched this file yet. So that is what de novo is. Just losing all the connections of de novo, once you have done that, you will be able to get the clean files of the game, and you will be able to hack into it or create the modifications for that easily, right? Recording of the session, Nipun and Sanjeev sir, please go ahead with the answer. When would the recording of the session would be available? Because the organizers have the link and organizers
Yes,
have
sir.
those
It will
links.
be available on
So, okay.
Sanjeev sir's YouTube channel, and we will be uploading it in 2 or 3 days maximum. We have a
Okay.
WhatsApp
Any
group.
other
We
doubt
will share
that
it
you would
there.
might have? Okay, so this is the QR code for my LinkedIn, right? Just in case if you want to connect with me on LinkedIn, you can just connect with me over here, right? Also, my Instagram and LinkedIn both have the Sanjay official over there. You can also just go over to what we can say, Google and search for Sanchay Singh or Sanchay Official, you'll get my profile. Right. Just in case if you want to email me, it's sanchayofficial@gmail.com. Right. The QR code would take you to my LinkedIn profile if you just want to connect with me. If you got any kind of doubt or any kind of thing, you can just connect with me anytime. I am available over there. Right. Also, yeah, on my Instagram, I roast cybersecurity people, right? Basically, not the cybersecurity core people, but the cringe content of cybersecurity. I really love to roast that. And in the Hackers Villas Instagram channel, I basically teach with the reels, right, in the short content. On YouTube as well, on Hackers Villas YouTube as well, I try to create such videos, right? 1 hour or 40 minutes videos. So you can just go through and check out that as well, right? Okay. So there's some questions more. Thank you so much for the wonderful session. Thanks a lot, Dhruv, for being in the session. And okay, so Sanath has shared a resource. Thanks a lot. Okay, session was really awesome. Both parts of the session. Thanks a lot, Sanjeev. Sir, then we have, can you tell how deep dive into threat intelligence, if you can give an idea? So threat intel would take you to the level of forensics you would have, right? So if you get a good knowledge of OSINT at forensics, you can go into threat intel. So make sure you have the good skills of OSINT and you have the good skills of forensics. And for OSINT and forensics, for the basic part of it, you can use TryHackMe, and Nipun is there to provide you with the pro edition of TryHackMe as well. And also, just in case if you want to go very much advanced into it, there are a lot of other OSINT resources that you need to go forward into. But you need to have OSINT and good forensic skills for threat intel. Okay. Thanks a lot, LA. Thanks a lot, Krishna Kumar. Thanks a lot, Dhanush. Okay. So yeah, okay. So thanks a lot, guys. Right, and it's 10 already. So thanks a lot for having me over here, Sanjeev sir and Nipun. Right, hope so everyone liked the session and tried to learn something from it. Even if you understood 10% of it, my work is done. If you have got a little bit of fire in yourself to learn about these things, my work is done. Okay, so we'll see you with some other sessions, right? If Nipun allows and Nipun basically organizes other sessions, I would be all-heartedly would come here for some other sessions as well. Okay, so thanks a lot, guys, for having me. Over to you, Nipun.
Thank you, Sanchay sir, for this session. Like connecting on a weekend at this time means a lot, sir. So we got some 150 registrations, but in the starting the count was 50. But lot of people messaged me for the video recording and all. I think it will be beneficial for them. And sir, we have a WhatsApp group actually. Uh, it was initiated by Sanjeev sir. So in that group, we are sharing job. Sanjeev sir is sharing job descriptions and all. Lot of people are there. Like there were some 1,000+ people in that WhatsApp group. There are people having 10+ years of experience. There are students as well. So everyone is helping each other. So as a part of that WhatsApp group, it was my contribution to that WhatsApp group for this learning. So moreover, I will be sharing. Sanjeev sir shared that WhatsApp group in the link.
I
I will
have
be sharing.
shared. I've
Yes,
shared
sir.
both. I've shared both the WhatsApp group name with the link and YouTube channel.
So I have a feedback form, guys. I will share in the chat box. If you have any feedbacks or suggestions for us, you can share it there. Uh, Sanjeev sir, do you want to say anything? This is all from my side.
Yeah, thank you, Nipun, for your effort, and Sanjay. This was really a very good session. The first part, actually, I was just it was like a very nostalgic for me to read all those assembly languages, C++, and especially like I had used GDB, I think till 2015, and after that I moved to AppSec and CloudSec side. But yeah, this was really a good session, and I think it will be really useful for lots of game hackers and the other reverse engineering people. So yeah, I will upload all these things, and I would really like to see another session from you, Sanjay.
Thanks a lot. Thanks a lot, sir. Sure.
Yeah, so guys, if you have some time, you can go through this form link. This will help us to understand like what all other sessions you want, and we can invite the industry expert people like Sanjay and other one. Even I will contribute lots of things from the AppSec and CloudSec side. So this form will help us to do more for this community. Yeah. And thank you for attending the session, especially on Sunday night, because tomorrow lots of people has to go to college and office, and still you guys are here. And Sanjay, you are in your hometown, and you took this time, especially on the Sunday night. Thank you for that.
Thank you, sir. Thank you. It's always a it always feel good to give back to the community.
Yeah, of course, of course. Yeah, yeah. Thank you, guys. I think I will just stop the recording, and then we'll share the recording in a couple of days. Yeah. Thank you, everyone. Take care. Bye bye.